So here's where I'm at currently on this 486DLC core card. I can't say I'm quite happy with the layout yet. I have some additional steps I'm going to make, but I thought I would just talk through maybe where I'm at right now on it and what I think my next steps are going to be. So first of all, some of the things you'll notice, the first one, let me just get into these three PSOCs. And I've placed the PSOCs directly on the PCB now. So I have my PSOC for my generation of all these miscellaneous signals I need. I have another PSOC for all my decode, and then another PSOC for this initial startup shadowing that needs to be done. And I found those to be a little tricky just to get them onto the PCB. And if I jump over to the data sheet for those PSOCs for a second, what I did is I came in, basically this is the user manual for the PSOC, and they have a schematic, and that schematic just shows me two things: what's on the little programmer part of the PSOC, which is the part I snap off, and then the actual PSOC itself. And then with that, just showing how it was set up to these pin headers that I've been using up to this point, along with some other supporting circuitry for that. So I took the parts of that I needed and put that into my actual schematic. So if I come over to my schematic, I can see here I've got three PSOCs, and I basically wired this up so that it will give me all the functionality I'm looking for and not necessarily load up all the extra components that I don't really need. And part of that is for example, a pin header to do the programming. So when I come back over here, you'll see that there's a PSOC and then there is a pin header. That's where I'll plug in my programmer, and I can program, update basically the PLD functionality of this PSOC or this PSOC or this PSOC. They each have their header nearby. I have had issues where I have these PSOCs inside of a larger circuit, and the programmer has issues when it's inside of a larger circuit. So whether it's something pulling down, likely something pulling down one of the signals that's used for programming. So you'll see these little jumper blocks. This will allow me to pull jumpers and completely disconnect the programming lines from the rest of the circuit. So if I do run into an issue where I can't program it in the PCB, I can pop these three jumpers off, and that should completely isolate the programming side of it. That would just feed me power, ground, and then these three programming signals. And I might want to also add, I'll probably do this now that I think about it, two more pins for the power and ground, the VCC and ground. So I can completely pull these 5 signals from the entire board so that I can program this, and maybe that way it's not going to try to provide power to the whole board when I plug in the programmer. But anyways, that's what these pin headers here would be for, is just jumpers. So I need to make note of that. Maybe other things as I was going through that, if I jump over to the data sheet for the actual PSOC itself, so this manual right here is for this entire prototype board, which, let's see if I can go up and get to a picture of that looks like this. And this is the PSOC I'm using. Well, my intention is just to put this PSOC directly onto my main PCB. Well, if I jump over to this document here, this is for that specific PSOC, and I'm looking at the the physical characteristics of this package that I'm using. And this would be the one that is on here that I see like this. So a couple of things with this, as I get into this, this is going to be a new soldering challenge for me. I've not tried to really solder these types of QFN packages before. And something else I've had to do, or I have done, and I'm definitely looking for feedback on this. When I look down here at these, we're looking at 0.2 millimeter for these connections. And really, I've defaulted on my PCB to 0.254 millimeter. So that means I either need to come out with a smaller trace and then switch it over to a wider trace, or run all the traces from this to where they connect to with a 0.2 millimeter, and then everything else on the board go to move it to a 0.254. What I've actually done is over here, and you're going to see that I have some incomplete traces. I'm going to come back to that in a minute. But I've just set the entire board to use 0.2 for my trace width, so 0.2 millimeters. And then I shrunk down my via diameter and drill diameter by about the same ratio. So I went from a 0.254 down to 0.2, roughly a 20% reduction, and then did the same over here. It seems like as I'm reading and I'm using the online calculators for trace size, and the idea that I'm pulling VCC and ground right nearby, I can pull those off the inner planes. It seems like I should be fine going with this type of a trace width and via diameter and via drill diameter. But definitely curious from many of you if you think this is an unwise type of change for this entire PCB. So if these PSOCs are going to have that challenge where if I get into this, the trace right now, its width is pretty much the size of this pad here coming off of each of these. So that's a change that I've made is, okay, I got the PSOCs on here. I pulled the trace size down slightly just to match the pads on this set of PSOCs. My vias have been shrunken at the same ratio. I'm not expecting any high currents on any of these traces that would exceed the trace size here, but I could be wrong on that. Something else that, as I've gotten into this, you'll notice, the board is compressed further than what it has been in the past. I've done a little bit of cleanup and just really tried to put some thought into placement of these things around the PSOCs. I've tried to lay out things in a better way on the board. You can see I'm down now to a 16-bit ISA slot plus this PCI extension. And so the length of this board has come down quite a bit. I've pulled down the height of this board. And if I go and look at those dimensions real quickly, you can see I'm looking at about 245 millimeters by 139. So I'm at about 5.5 inches by 9.7 inches. So the board is reasonable sized. It still ends up being, at least the way this is set up, as an 8-layer board, which is where I have it right now. It's still about $120 for this set of 5 boards for this. Now, I guess I'm just using the auto router for now, again, really just to test where I'm running into problems. If the auto router can get through it, then I've got a fairly decent confidence I should be able to manually route and do a better job than the auto router. Might take me quite a while, but I think I should be able to beat the auto router. Here I can just see the auto routers where it's running into problems, and I can see that really getting out of all of these really tight connections on the PSOC is what I need to focus as my first manual step along with my clock signals. It's just get all of this away from the PSOC and connected and routed before worrying about some of this other stuff. You can just see how tight things get. It looks like every one of these PSOCs has at least one signal that it had a hard time doing something with on the auto router. And so like in this case, there's one signal here that it needs to get down to this resistor. Now, of course, I can change the layout of these, and I'll probably do that so that this might be closer over here to the left instead of coming across all the way to the right. So I've got some manual work to do on these PSOCs. But that's one thing that's been tricky as I've gotten into this, is just trying to get the PSOC laid down in a way with the capacitors nearby, and then any resistors that are these inline resistors, and any of these connectors like for programming, which just seems so gigantic now that I'm working with this tiny little component. But I guess that's kind of what it is. Maybe some other commentary on this. I did experiment with placing components on both the front and the back. So on this, you're going to see that pretty much the only thing on the back is just an LED to indicate power for me. And that's because this will probably be plugged into the system facing this side towards me because of how the chassis works. To the left is the back of the chassis, and I have that so that that is to the left of me as I'm working on it. So this will just let me see I've got power to the card real quickly. And it looks like I've got a couple straggler components I need to move back over to the front. But I did experiment with moving things to the back. And I didn't find it necessarily helped me unless I was going to go to a higher number of PCB layers. So for example, I did try to, maybe take these here and place them on the back somewhere in this region. And it just got to be too much. And the routing was quite messy to try to make that work. And then I also thought about when it comes to me, I'll call it manufacturability and serviceability, but for me to actually lay out this board with the inner copper in it, I expect I'll probably be using my hot plate to at least warm up the board a little bit, and then I'll use my hot air gun to actually do the soldering. And for me, that got a little bit of a concern if I want to have components on both sides and want to use the hot plate and soldering or hot air soldering station. I'm sure that's a possibility and people do that, but I'm probably more comfortable if it is all on one side, so I can set this down on the hot plate and do all the work on the top side. And that's both for the assembly and then also for the ongoing, if I'm going to have to pull a chip or do something, I want to be able to get to all of that stuff on the top for the most part. I did try it. I did do some layouts with it and just didn't get to one that really jumped out as the right way to place things on the back side. So if any of you are experienced on placing components front side and back side on a 4 or 6 or worst case 8 layer PCB and have suggestions of what type of components here might make sense to throw on the back, let me know your thoughts. But right now I've got this all on top, other than some that it looks like I forgot to, or I missed when I wanted to pull it back. So that would be, it looks like a couple of these on this upper P-sock, and that is, looks like P-sock number 2. So I'm gonna just jump over here to P-sock number 2 and correct that here real quick. So I'm going to come in and find those couple of capacitors that should show up as a different color. And so we've got a couple of these right here. So I'm going to go down and edit the bottom layer and see if I can just grab those two. And I'm going to bring those up to the top layer. And while it's doing that, because this will take a second, I will just mention EasyADA is a pretty poor PCB design tool once you go to inner planes. You pretty much, every time I want to really work on the board, I've got to go in and get rid of the inner ground and VCC planes. Otherwise it does what you're seeing here. It just struggles. I made a change and it takes 30 seconds to make one simple little change, like moving these from the back to the top. I'm sure the answer from EasyADA as well, you should now be using the Pro version. Yeah, sure. But I've tried that, and I've also been dissatisfied with that product because it just does not have the library of components available that the EasyADA standard or the free version has. But I'm moving my mouse here and I can see it's still, processing this simple request. And when it gets done, I'll real quick go in and change a setting and show you what I have to change every single time I want to move things around, and then have to change back before I go back into my routing. If I'm going to use like an auto router as an example. Now, if I'm doing everything manually, then some of this is maybe less of a pain, but still I find that EasyEDA does not work well if you have inner planes. And I think it might be particularly inner ground planes, but I get rid of both the ground and the VCC. If I get into the auto router I'm using while I'm waiting for this, since it's still thinking hard, I've just been using this router here, this free routing. It does have routing options, and I've just been experimenting with these just kind of for the fun of it. But it shows me how it set up the preference for, my top layer is going to be a horizontal The bottom layer is going to be a vertical, and these inner layers. There is an option to do fan out, and so it tries to fan out of this a little bit before it gets going, but I notice that it doesn't do it enough, and I haven't found a setting to control that any further. I can also come in here to some of these other router settings and set up things like what is the cost, in its algorithm, its calculation of how it does routing, to put things on the top layer, bottom layer, middle layers. If I'm saying a top layer should be left to right and it has to take something vertical, it increases the cost as it calculates that. So I can experiment with these, and these are not the defaults. I just kind of this is what I changed this to for this last auto router session that I was doing. And again, I'm doing this just to kind of quickly experiment with, can I get the board in general routed? And if I can't with the auto router, it doesn't mean I can't do it entirely manually, but it means I'm going to maybe have a little bit harder time. I hear my CPU fans went down, so now if I come back over here, this finished what it was doing. But I'm going to change a setting here real quick in my copper setup. I'm just going to change all these planes to signal layers for now. Signal. And by doing that, I can now make changes, and it will be responsive and not essentially lock up for a minute every time I try to touch something. So I can now update the rest of this, if I wanted to move these caps around a little bit. And for example, I can drag this over and, it jumps out of it instantly, like I would expect. But I'm going to undo that. This just means that as I get done making changes to my layout, I need to remember to come back into my copper and change those back to the appropriate planes, as far as, this back to a plane instead of signal. So if I keep going with this, you will notice I have whatever it is, 1, 2, 3, 4, 5, 6. So maybe 6 incomplete, and maybe there's a couple more down here too that it couldn't. I don't know why it couldn't figure out how to connect these over, but you can see it did struggle getting everything fully routed. I think it was 20 if I go back to the auto router. Let's see if it shows it down here. I could even just say start auto router. And yeah, so right down here you can see it, how many it has. 18 to route. It made 2, it ripped 3. So, I can count that up, but that'd be 20. So 2 were routed, but 3 were ripped. Let's see, 22 actually. So that means I've got 11 connections that are not, getting done by the auto router. It's stuck. Like this one looks like such a simple one. And if I come up to that, I should see that one up here, is this guy right here. And it's trying to simply connect this pin up here to this one pad, but you can see everything that's in the way as it does that. The auto router apparently isn't doing this very intelligently to be able to get this out of here. So that's where I probably need to manually pull this out, spread out these connections a bit as I pull it out. But something the auto router is not doing well. So this is where I'm at on this. Let me go back to the 3D view for a second. What else is on here? I think a lot of this stuff has been, similar to previous versions. Again, I've got an oscillator that I can swap out. I've got my clock distribution chips. I've got some just miscellaneous logic type of chips. This is a latch for some expanded control signals in the future if I need them. And then I've got my data transceivers down here, my address latches up here for my shadowing process, my RAM, etc. Most of the rest of this is pretty straightforward. But as you can see, just the auto router did not get through, could not get through this entirely. And it definitely is not optimized in any way. The way this auto router works is it's trying to complete these connections, and once it gets them complete, then it'll go into a phase where it tries to optimize everything. And I can't even get to that optimization phase with this as an 8 layer. And I don't think I'll have any better luck with this a 6 layer. So I'd have to go above 8 layer, and that's off limits for me. It's just too expensive. And really, I want to get this down to a 6 layer, or even better, a 4 layer, but I don't know if I'll be able to get that far. This is just too much. So that maybe takes me to my next steps, what my plan is. I think I'm going to pull this down in size even further. And here's what my intention is next. I'm going to pull off anything that really isn't necessary for the core processor. And let me clarify that. So this PIC, for example, I don't need the interrupt controller to be on this card. I can place that elsewhere. So I'm going to pull the PIC off. That, again, is a priority interrupt controller. These address latches over here and the shadow PSOC, I'm going to also pull those off of this. So I'll be able to pull these 3 chips and this shadow PSOC off. And then also the flash ROM I won't need on this card, so I can pull the flash ROM off. And my intention would be to place really, this PSOC for the shadow plus the ROM itself that gets shadowed into RAM, plus these latches and any other supporting pieces that go with the shadowing process onto a separate card. Because it's really just using address lines, data lines that are essentially on my bus anyways, on the ISA bus. So that is something I think I can pull off, pop it onto a separate card that just plugs into the ISA portion, or maybe ISA and the extension. But I could cut this card down a bit. And really it's cutting it down in complexity, so that would be good. And I'm going to see if I can get that down to a 6 layer or maybe even a 4 layer if I leave it spread out a bit. And I'm going to have to do a bunch of manual routing work with the PSOC right away just to see if I can help the auto router get through it. Again, trying to just simply validate that I can get it auto routed or 80% auto routed in general. And then if I can turn around and maybe do some better work on a manual side as I try to learn how to do that decently. Also, what I could do is on this card, for at least the core card, and maybe this other card that would have, for example, the flash ROM functionality, I could maybe, instead of the ISA slot 2, just go with maybe even a single just proprietary connector that's a PCI that gives me just the signals I need to get to that other card, or a pair of these PCIs that really give me all the signals I need into some form of a backplane bus that might have ISA connectors on it also, but maybe for some of these core cards, it doesn't really matter what I use for a connector. So maybe I might just try more of this condensed type of PCI connection instead of an ISA type of connector. Pros and cons there, I suppose. I'm guessing these PCI connectors are going to be a little bit more delicate than these ISA connectors. These ISA connectors have been really solid. As far as the actual slot connector, it seems like it's hard to cause problems in those slot connectors. And these slot connectors are inexpensive, whatever they are, 30 cents versus 80 cents for the PCI connectors. So I'll do some experimenting with that. So I'm not going to rush into ordering up anything. I'm going to just kind of keep experimenting here, and I don't know, see what I can learn as I go. This has been pretty interesting, just trying to go to this much smaller form factor for this IC, for this PSOC. So I'm learning that it takes some thought and some discipline probably to route these properly, and I'm not quite there yet, so I need to keep working on that. I'm trying to think if there's anything else. I think those are the big things. So, I did experiment again, front side, back side placement. I didn't find anything on the back side that really made a notable difference. I could compress size, but then it only increased issues on routing. I do have the PSOCs pulled off of their prototyping carrier board, placed right onto the PCB. So I think that is going to be a really nice change, not having to deal with the small PSOC carrier boards. So we'll see how that goes. I'll get to practice soldering around that type of placement, which will be interesting. I have to experiment with my actual slot connectors here and see how that's going to fit into the chassis and how many slots I'm going to be able to fit in one of those cases that I've been using, that open frame case. Again, I reduced my connections here from 0.254 millimeter to 0.2 millimeter for all my traces, and also pulled down the via size in the same manner. So I'm still at version 0, have not gotten to the point where I'm going to order this up yet, but next video I'll probably have broken this out into one size smaller and have a pair of cards that try to get this functionality covered. So if you have any thoughts on how I'm approaching, placement of these PSOCs, the actual vias and traces that I'm using, how I'm approaching some of this back here in the design settings, let me know. So more to come as I try to pull this down in size and complexity in the next step. And if I can get that working, then I'll build out the card that goes with it to do my shadowing, followed by the IO card that has a bunch of my miscellaneous IO on it. This is where I am pausing for now.